Galilean telescope furnishes erect images, but has an extremely narrow field of view, which rapidly diminishes with increasing magnification. If, in fact, the field of view of a Galilean telescope with 20 magnifications is indicatively 15 minutes, that is, about half the apparent diameter of the Moon, it decreases to the order of only 5 minutes in a telescope with 50 magnifications. Such limited fields not only made the Galilean telescope unfeasible for civil and military purposes, but above all prevented in the astronomical field increments in performance over a few tenths of a magnification. Johannes Kepler, the German astronomer famous for his 3 laws on planetary motion, had however demonstrated since 1611 the possibility of replacing the diverging eyepiece of the Galilean telescope with a converging lens, with the ensuing advantage of a much vaster and more highly contrasted field of view. But this optical combination, known today as the Keplerian or astronomical telescope, furnished upside-down images that made it unsuitable for terrestrial use. Galileo was to remain always faithful to the optical combination that bears his name. However, in the 1630s, the Keplerian telescope began to be widely used, mainly due to the work of the Neapolitan optician Francesco Fontana, to the point of entirely superseding the Galilean one toward the middle of the century. The last great astronomical achievement made with a telescope of this type, published by Hevelius in 1647, was the representation of the lunar surface. Moreover, the Keplerian telescope soon predominated for terrestrial purposes as well, thanks to the introduction of the so-called erector, an optical device usually consisting of 2 convex lenses with the same focal length, which turned the image produced by the objective upright. Various materials and techniques for making the tube were experimented by the first telescope makers. The little telescope examined by Giovan Battista della Porta in Naples in the summer of 1609 had, for example, a tube made of tin. To build his first telescope, Galileo used instead a lead tube, while that of the instrument he presented to the Venetian government was made of tin plate covered in rascia, a fabric made of raw wool that was to be used in Venice to cover gondolas up to the end of the 19th century. The only 2 surviving examples of Galileo's vast production, now in the Institute and Museum of the History of Science in Florence, both have wooden tubes. One is made of 2 hollow half-cylinders covered in paper and held together by 4 copper wires. The other is made of 20 strips of wood glued onto paper and covered in red leather with gold tooling. Later, the tube became standardized. As telescopes grew in size, it became telescopic, that is, made of several sections sliding into one another, to reduce its size when not in use. The preferred material became cardboard, lightweight but able to provide the necessary rigidity. The secondary sections were often covered in marbled paper, and the main section in finely decorated leather. In the telescopes of English make, the eyepiece was usually housed in the tube of largest diameter. The housing of the optical parts also became more sophisticated. Often fabricated by lathing fine cabinet woods, either domestic like boxwood or exotic like guaiacum, they were fitted with screw caps to protect the optical components.